Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we are going to start a new course titled Mechanics of Staple Yarn Formation. I am Professor Apurva Das from Department of Textile and Fiber Engineering, IIT Delhi. So, first I will briefly tell about the overall outline of the course. So, the overview of the course is that we will start with the module 1, which is Blowroom, that is the initial fiber preparation, mainly the staple fiber preparation for long spinning process. Okay. So, there are series of machineries required to produce the yarn, staple yarn, and blowroom is the first process, and in this course we will discuss only the mechanics part. We are not going to discuss the production and technology part. Okay. So, the blowroom part will include, first we will see the mechanics of opening and cleaning of the fiber tuft, then estimation of effectiveness of opening and cleaning systems, characteristics of reserve box. Reserve box is very important because it is the process where we reserve the fiber, and we actually it is after the blowroom process the fiber goes to carding. So, that the transportation and how the construction of the box, reserve box affect the process, that we will discuss. Then the air feed, chute feed or flock feed system. So, which is actually from the blowroom, the how the fiber transportation is controlled, that we will discuss. Then the blending is important part of blowroom. So, how the blending takes place, what are the mechanics of blending, and how to select the blend constituents, that we will discuss. And depending on the blend constituents, the process changes, blending selection of blending process changes. Then mechanics of blending we will discuss at different stages, how the blending takes place. And another important term we will discuss in detail, which is blending delay time. So, how to calculate blending delay time for different number of segments, and also we will derive the generalized formula for to calculate the blending delay time. Then we will see how the mixing takes place. So, by the term uniformity of mixing or blending, that we will see what is the implication of the quality of the product, and finally assessment of blend irregularity. So, blending index, that we will see how to calculate. After blending, next process is carding, where we individualize the fiber with the help of a series of wired pinned surfaces. So, that is extremely important, and this is the only process, first process, where the fibers from the tuft, that is this is a tuft form, we get the fibers in the tuft form in blowroom, and then we get the fibers individual identity in the carding process. So, where the individual fibers can move without actually affecting the cluster, that adjacent fiber, neighboring fibers. So, that is possible where we actually process the fiber through a series of pinned surfaces, that we will discuss in detail. So, here what we will be doing, so carding and stripping or doffing action. So, we will see the mechanics of carding and stripping action, then classical theory of the carding operation, that we will discuss here, behavior of carding during transient state, that means at the initial stage when we will start, when the carding machine starts, the carding is actually loaded, there is no load in the card, no fiber loading in the carding. So, initially when we start the machine, so how the loading takes place, that we will discuss here, and also when we stop the feeding, we stop the fiber feeding at the end of the, when we want to stop the carding action. So, how the loading changes at a different part of the carding machine like cylinder, doffer, that we will discuss here. And then the cylinder is the only part where the fiber load is consistently there. In Licarin, from Licarin actually fiber goes directly to the cylinder through stripping action, and from the cylinder it portion of the fiber gives to the doffer, and from doffer 100% fiber is actually stripped out to form the sliver. So, cylinder loading is extremely important, like this is a cylinder, here it is a Licarin, and now here doffer. So, Licarin moves, Licarin takes the fiber and then it gives to the cylinder, and then it is a doffer, Licarin, cylinder and doffer, and doffer, from doffer fibers are stripped in the form of web. So, in doffer and Licarin the continuous fibers are not there, but in cylinder you will see throughout the cylinder fibers are wrapped. So, it is important to know the loading of the cylinder, that we will discuss in this section. And next we will discuss fiber transfer efficiency. So, fiber transfer efficiency is very important, and it cannot be, it should not be very high or very low. So, that we will discuss. So, how the fiber gets transferred from the cylinder surface to doffer, that is important, and their implication. If it is very high transfer efficiency, suppose directly fiber comes from cylinder, 100% fiber is transported from cylinder to doffer, then we have the, it will have the impact on the quality, that is the blending will not take place, and also if it is low, then transfer efficiency is low, then there will be loading on cylinder. So, that we will discuss, and we will theoretically we will try to see the how the transfer efficiency affects and how is it calculated. So, then response of the card to step change in feed. So, so if we change the feedings, like what we are doing, there is no loading or certain loading is there, suddenly we have changed the feed rate. So, like your from the Blowroom suddenly the feed rate comes. So, how the card will respond, that we will discuss in this section theoretically with the help of diagram. And mixing action of card. So, that we will see that how the carding actually has action of mixing. So, mixing action. So, during this carding fiber gets mixed. So, that mixing action we will discuss here in this section, and last we will discuss some recent developments in carding machine. So, after carding we will then discuss the mechanics of drawing process. So, drawing is also an important process in staple spinning, because it has got different functions. So, that we will discuss, but here the mechanics what we will discuss, it is a ideal drafting mechanics. So, that we will see the what is the ideal drafting. Through the diagram we will try to understand the ideal drafting mechanics. Then geometrical analysis of fiber movement during drafting. So, how the fiber moves through the drafting zone, that we will see. The floating fiber movement we will see, then drafting force calculation, mechanics and ideal drafting, and how the drafting force is calculated, and different parameters which affect the drafting force through numerical, through derivation we will try to understand. Then mechanics of drafting wave generation. So, how the drafting wave is generated during drafting, that we will see. Then theory of draft distribution. So, draft distribution, how the draft distribution is affecting the quality of the product, that we will discuss. Then nipping of sliver by roller, that is roller eccentricity, roller sleeve, analysis of roller setting, all these things we will discuss in this section. Then mechanics of blending and blending delay time in the draw frame. So, earlier what we have discussed blending delay time in Blowroom, but here also we can control the blending delay time. What is blending delay time, that we will discuss subsequently. So, mass variation in draw frame sliver. So, in draw frame sliver, draw frame, one function of draw frame is that to reduce the mass variation by doubling, number of slivers are doubled. So, we must know the how the mass variation is controlled here. Okay. And also we will discuss here the draw frame, the open loop, closed loop system, that we will discuss, that to control the mass variation. And one important function of draw frame is the hook removal. So, we will see the theoretically the hook removal, theory of hook removal in draw frame. Next module will be mechanics of combing process. So, combing process is also an important, although it is optional, for if we want to have a better quality, superior quality of product. So, there combing is important, where we remove the short fibers as per our requirement. So, combing sequence of short fiber and long staple, short staple and long staple fibers are entirely different, that we will try to understand why they are different. Then fractionation of fiber of the specific length and Noel theory. So, if we want to remove the fiber for a particular length, so that is possible in a comber. Suppose in a fiber, in a sliver, we have different fiber lengths possible. Suppose if we want to remove a fiber of certain length and certain lower than say 10 millimeter, lower than 10 millimeter length, if we want to remove, that is possible in comber. Okay. And Noel theory. So, how to calculate the Noel, that amount of Noel, that we will discuss here. And development in comber. So, different developments we will discuss, and detaching roller motion through epicyclic gear arrangement. So, in comber we will see the detaching roller has got a special motion, like your fast forward, then slow forward, and the backward motion. So, this total complex motion is achieved through the epicyclic gearing system. So, this epicyclic gearing system in comber we will discuss here. Then mechanics of roving process. In roving, basically its function is to reduce the thickness, reduce the linear density of the sliver, which will be required for the ring frame. So, roving is also used only for ring spun yarn, but roving is not required for the other yarn like open end yarn, rotor spinning or friction spinning. Roving is not required. So, because in ring spinning we have roller drafting system. In roller drafting, for suppose in a sliver, from sliver, this is sliver, and if we want to get yarn, we need approximately say 400 to 600 say draft. So, this much draft is not possible in a roller drafting system. So, that is why to share the some draft in a sliver, we have one additional process which is a roving process. So, which actually shares suppose 10 draft, 10 draft if it is sharing, that means the ring frame, in ring frame it will be 400 by 10. So, if we 40 draft is possible in ring frame. So, that is given in this roller drafting system. That is why in roving is important for ring spinning. So, roving, in the roving we will see that how the twist is inserted and false twist is real twist and false twist are inserted. Then winding on roving bobbin is important. So, for that it is another it is a complex motion, because in a roving bobbin the speed you have to change with the diameter. So, it is unlike ring spinning where spindle speed is constant. Here although spindle speed constant are like flare speed constants, but the bobbin speed changes, and it is changed through the again differential gear arrangement, that we will discuss here, the mechanics. Then cone drum belt shifting mechanics is important, which is actually to change the speed of the bobbin. Okay. Winding tension in flare leading system. Flare leading system is a simpler system which is used for jute and flax system, where it is the tension is actually has to be controlled. That we will discuss how, what is the mechanics of tension control in the jute or flax roving. In addition to this, we will also do some numerical calculation. Okay. Then coming to the rings module 6, which is mechanics of ring spinning. The spinning balloon and balloon tension we will discuss in detail. Forces acting on the traveller, what are the different forces acting on the traveller, that we will discuss. So, then yarn tension in ring spinning, which is extremely important, because otherwise the yarn breakage takes place. So, that to control the yarn breakage we must understand the yarn tension. So, how mechanics of yarn tension we will discuss here. Then spinning geometry and spinning triangle. Spinning triangle is also very important for fiber breakage or fiber migration. So, yarn breakage, fiber migration. So, that yarn spinning triangle we will discuss here. Then cam devices in ring spinning. So, different cams are used in ring spinning. So, they are mechanics that we will discuss, because cam is used for basically that ring rail movement. Ring rail movement is not a simple movement. So, it has got a complex movement that we get this ring rail movement through the cam. Then ring traveller speed relationship and twist compensation. So, twist compensation is also very important in ring spinning, because the twist in ring frame is, we normally know that it is spindle speed divided by delivery speed, but actually when the twist is inserted in ring spinning, it is Nt by Vd, because spindle is actually not responsible for twisting. Traveler revolution is responsible for twisting, because spindle helps the traveler to rotate, but they rotate at different speed, okay, rotational speed. So, if we calculate the actual twist inserted during ring spinning, it is a Nt by Vd, which is present in the ring bobbin, okay. But we will see the Nt, that is traveler speed, changes, and it is dependent on the diameter of bobbin. Traveler speed is dependent on the diameter of bobbin. So, as always you will see that in the ring spinning always diameter changes, okay, within the traverse, even during the building of the package. So, Nt always changes. So, that is how the twist, actual twist in the bobbin is always changing, it always varies, but during unwinding from the from the bobbin, the twist gets compensated, and where after compensation the remaining twist after unwinding into the package like cone or cheese, larger package, twist gets compensated and it becomes Ns by Vd. So, in the package if we see the twist become spindle speed by delivery speed. So, that how is it getting compensated, that we will discuss in this section, okay, with the example, and ring and bobbin diameter relationship and angle of lead. So, the angle of lead actually affect the yarn tension, that we will discuss. Next is the mechanics of rotor spinning. So, after conventional ring spinning, then rotor spinning we will discuss here, where the feed material, as I have already mentioned, instead of roving, here feed material is the sliver. So, rotor spinning mechanics we will discuss here, then how the twist is inserted, and we will see the calculation, twist calculation, and cyclic aggregation of fiber. So, within the rotor, how the fibers are getting deposited. So, that we will see in this section. Then fiber ring formation, fiber flow calculation. So, how the fiber is flowing from the opening roller up to the bobbin formation, that we will calculate. Okay. And our last segment is mechanics of friction spinning. So, formation of friction spun yarn structure. So, how the yarn gets formed and their structure. Analysis of twist insertion in friction spinning. So, how the twist gets inserted, then friction spinning process development. So, there are different friction spinning processes are there. So, that we will discuss, and we will stop here, and our next module will start with the blowroom, and we will start with the section opening and cleaning in the blowroom. Till then, thank you.